Guys, so in this lesson, we're still in section 4.3. We're doing the opposite or the reverse of what we did yesterday. So yesterday we used the properties of logarithms to expand logs. Today we're going to go in the opposite direction. We're going to condense the logs. So we're going to take multiple logarithms. So like the addition of two logs, we can condense using the product rule into a product of one log. Subtraction, we can condense into division. The power rule, remember that p, that power we had in the front, we're going to move it back to the exponent position. So we're going to use the same properties we were using yesterday, but now we're going in the opposite direction. So let's take a look. Example 1, it says condense the logarithmic expression. So in other words, write it as a single logarithm. Fractional exponents should be changed back to radicals. So let's look at letter A. We have log base 4 of 2 plus log base 4 of 32. So think about what can we do with that. We're adding the two logs, so to go backwards to condense, we have to change it to what? Addition turns back to multiplication. So we're going to change this to the product of the two arguments. So my two arguments are the 2 and the 32. So I'm going to write this as log base 4 of 2 times 32. Now since those are numbers, I'm going to go ahead and multiply it. 2 times 32, of course, is 64. And just like always, if you can simplify that number because of the base, go ahead and do that. 64 can be written as a power of 4. 64, remember, is 4 to the third power. So I'm going to replace 64 with 4 to the third, and I'm using that because the base was 4. And then I have log base b of b to the x. That is my inverse rule right there. So this will just simplify to 3. So just like always, if you can simplify the number, you want to go ahead and do that. Let's try letter B. We have log of 4x minus 3 in the argument minus log of x. So log of parentheses 4x minus 3, close parentheses, minus log of x. So since we're subtracting the two logs, then to condense it, we need to go back to division. We're going to use the quotient rule. So the log that's positive is going to be our numerator term. So we're going to have log of 4x minus 3 is going to go in the numerator, and x is going to go in the denominator. You can put parentheses around the whole thing if you want to. You don't have to. What I do not want to see in a question like this is this. A lot of times students, when they try to condense this, they write two logs. When we're condensing into a single logarithm. That's really important. So I don't want to see log over log. That is incorrect. I want to make sure we do log of the entire argument, 4x minus 3 over x. And that would be fully condensed. Let's take a look at example C. We have 1/2 times log of x plus 4 times log of x minus 1. So remember when we expanded, the last thing we expanded were the powers, so that's the first thing we're going to condense. So if I have any numbers that are coefficients in the front, we're going to move them back to the exponent position using the power rule right here. So we're going from this back to this form of it. So this will turn into log of x to the 1/2 power plus log of x minus 1 to the 4th power. And then because I'm adding the logs to condense, I'm going to change them back to multiplication. We're going to use our product rule. So this becomes log of x to the 1/2 times x minus 1 to the 4th power. So if you want to put a bracket around this just to kind of show that that's your argument, you can do that. The last thing when we condense is if you have any fractional exponents, you want to go back to radical form. So x to the 1/2, how does that look as a radical? That's going to turn back to the square root. So we're going to have log of the square root of x times x minus 1 to the 4th power. I'll put a bracket around it for grouping. But that would be completely condensed. We have a single argument, and we're going back to radical form for any fractional exponents. All right, let's take a look at letter D. We have 3 times the natural log of x plus 7 minus natural log of x. So first thing is if you have any coefficients, move them back to the power rule, or use the power rule to move back to the exponent position. So this 3 needs to go back to the exponent. So we're going to have natural log of x plus 7 to the 3rd power minus the natural log of x. And because these are being subtracted, we're going to use the quotient rule to write it as a fraction. So we're going to have the natural log of x plus 7 to the 3rd over x. So my argument is x plus 7 to the third all over x. And that would be fully condensed. Letter C, we have 4 times log base b of x minus 2 times log base b of 6 plus 1/2 log base b of y. So what's the first step? We want to move those coefficients back to the exponent positions. So we're going to have log base b of x to the fourth for the first one, move that back, minus log base b of 6 to the second power, plus log base b of y to the 1/2 power. Okay, so now I see some subtraction, so these first two would turn into a quotient, and I see some addition. When you have multiple logs like this, what might be the easiest way to think about when you condense these is anything that's positive is going to go in your numerator, get multiplied together in your numerator. So like the x to the fourth is going to get multiplied by the y to the 1/2 because they're both positive. I could easily rearrange these so that the log, here, why don't we do that? Log base b of x to the fourth plus log base b of y to the 1/2. We can put those together if we want to. It's the same thing, isn't it? All right, so those are going to get multiplied together. Whatever's being subtracted is going to get divided and move to your denominator. So what we're going to have is we're going to have log base b of, here I'm going to do a big parentheses, x to the fourth times y to the 1/2 over my last argument here, 6 squared. I'm going to go ahead and make that 36. And anything, remember if you have fractional exponents, you want to go back to radical form. So we're going to write this as log base b of x to the fourth times the square root of y all over 36. And that would be as condensed as we can get it. Everything into a single logarithm. Let's try letter F. We have log base 5 of 25 plus log base 5 of 50 minus log base 5 of 2. So I'm going to go ahead and put the product, or I'm sorry, I'm going to use the addition to turn into a product. So we have log base 5 of 25 times 50, and then over, because we have a subtraction sign, 2. All right? So we need to simplify that. We can multiply 25 times 50 if we want to. I'm going to just do this. I'm going to divide 25, I'm sorry, I'm going to divide 2 into 50. 2 goes into 2 once, 2 goes into 50 25 times. So that leaves me with 25 times 25. So that would be log base 5 of 625. You can use a calculator though. You don't have to worry about that. 25 times 50 and then divided by 2, you'll get 625. Same thing. Now 625 happens to be a power of 5. So because it's a power of 5, we do need to go ahead and simplify it. Get your calculator if you're not sure. 625, I believe it is 5 to the 4th power. Let me just double check. Yes, it is. So 5 to the 4th power. So I'm going to write this as log base 5 of 5 to the 4th power. And then remember the inverse rule we talked about earlier, log base 5 of 5 to the 4th. That just simplifies to 4. So that worked out kind of nicely. The last example here, it says use common logarithms and natural logarithms to evaluate log base 5 of 140. Now let's make sure we're clear on what they're asking us to do. First of all, you notice that 140 is not a power of 5. There's no way for me to rewrite 140 as 5 raised to some power like I just did with that 625. I could write it as 5 to the 4th. I can't do the same thing with 140. So this is where that last rule, we haven't talked about it yet, the change of base formula. Let me show it to you back on the first page here. The change of base formula is what we're going to use to simplify this right here. So if I want to evaluate a log that's anything besides a common log or a natural log, because my calculator will operate in common log and natural log, but any other logs, if I want to calculate them, I have to use this change of base formula. So log base b of m can be written as the common log of m divided by the common log of b. It can also be written as the natural log of m divided by the natural log of b. So in other words, the argument goes in the numerator log, the base goes in the denominator log. Same thing over here, okay? So how does that apply to the problem we're looking at? So it said use common logs and natural logs to evaluate. That means they want a number, and it's going to be a decimal value in just a second. Let's do common log first. So log base 5 of 140, according to that change of base formula, I can write this as the log of 140 divided by the log of 5. Okay, so to evaluate this, I'm going to go to my calculator, and I'm actually going to type in my calculator, log of 140 divided by log of 5. So the keys, make sure you see where I'm getting these keys from. This log in your calculator is the common log. This ln is the natural log. So I want the common log first. So I'm going to do the common log of 140 divided by the common log of 5. And it's going to give me a decimal. And there it is, 3.07. They didn't say how to round it, so we'll just do 2 decimals. So this is approximately, I should say, 3.07. That's the value of log base 5 of 140. Now we could have also done natural logs and we'd get the same result. So we could also write this as log base 5 of 140 can be written as the natural log of 140 divided by the natural log of 5, as long as I have the argument on top. And I want you to see that if you go into your calculator, you're going to get the same thing. Natural log, so use the natural log key, of 140 divided by the natural log of 5, and we get 3.07. It does not matter which one you use, the common log or the natural log, but make sure you know this formula, this little formula to convert and to calculate logs that are in other bases besides common log or natural log, because we're going to use this extensively in the next section.